understand life? I love that line. Do you?
Do you understand?
So, hey, Tutankhamun, how are you doing? How are you doing tonight? It's late. Hey, 3D Fugue Tech Channel, welcome to the stream. Good to have you here. And everyone else lurking, lurking in the background. Say hello. Tell me where you're coming from. We're starting in a few seconds. I hope this is working. Oh my goodness, I haven't been online for so much time now. Such a long time since we have been streaming here. So, just to let you know, the stream chat is working for Twitch. So I'm currently streaming in parallel, running the stream on YouTube and also on the Twitch channel. If you wanna see your chat on screen, then hop over to Twitch. The video will be available on YouTube afterwards anyways, but I'm now using Twitch because I figured that all the notifications and all the stuff works much better on Twitch, for the live stream, and you can still watch it live on YouTube, but if you want to take part in contests and stuff and giveaways, we're doing this all on Twitch now. For example, everyone who's watching will earn nozzles. So we have kind of a virtual currency now that is called nozzles, and if you watch the stream on Twitch, you're gonna earn nozzles, I think for every 5 minutes or something. And then you can check your status, like if you want to know how many nozzles you have. Like I don't have any, but you can check how many nozzles you have anytime later, just by sending the nozzles command. So ! nozzles will give you your nozzles and your ranking in the leaderboard, and then later on, or in any of the following streams, anytime you can earn the nozzles, and then we're gonna do some giveaways, for example, and then you can just enter and basically put in your nozzles to yeah, as kind of tickets for the giveaway. So that's how it works. So you can earn as long as you watch, you're earning these nozzles, and then you can spend them basically on stuff. And later on, I have some ideas to use the nozzles also for, like, I don't know, turning on stuff in the background or turning on kind of some effects here in the studio. As soon as we start building the background wall, the idea is that we're gonna use the nozzles to I don't know, to send some messages into an LCD panel or something. So I have quite a few ideas for how to use the stuff, and also how to use stream alerts and stuff. That works all much better on Twitch, so that's why I was starting to stream on Twitch and using Twitch as the main thing for doing these kind of interactive stuff. And you can still join on YouTube if you just want to watch what's gonna happen. Mad Scientist, welcome to the stream. And good to have you here. The Twitch channel is basically the same as Daniel Crosslink, so I've posted the link, but I can also repost the link. Let me do it on YouTube. I think that's the Twitch channel. I posted it in the YouTube chat. I can see the YouTube chat, so if you're posting something in the YouTube chat, I can read it, but it's not gonna show up on screen because YouTube, basically Twitch's rules for restreaming are that you cannot show chat from two different platforms. Basically, it's against the rules. I mean, we can also ignore that, but anyways, that's how it works. I think it's also a little confusing because if you would see the chat from different platforms, then yeah, and someone answers on a different platform and then others cannot see it, I think it's a little confusing. So that's why I said for the future, I think it's good if we use Twitch, because we have more interesting ways to interact on Twitch, and we can have these kind of notifications, and we can have the giveaways in a much easier way by doing this earning the nozzles. That's our virtual currency. And yeah, as I said, if you go on Twitch and you hit !nozzles and like send it to the chat, you will see how many nozzles you already earned. So maybe you just want to try it out in the next couple of minutes to do that, just to see if it's working, because I've just used it myself, and for me it doesn't work because I probably cannot earn nozzles on my own stream. Obviously, it probably doesn't work. But if you want to try it, and after 10 minutes or so, you can just go there and hit nozzles and then see how many you have. And then for future streams, the idea, as I said, is to have them as a kind of a virtual currency, so you can put them into a contest, or you can use them to trigger some, I don't know, to troll me stuff. Here we go, 20 nozzles. And I think you can earn, I will tell you, I've also enabled, I think for following, you will get some additional ones, and for gifting and all that stuff. You can basically also earn some nozzles on a channel, and then once we do a giveaway, you can spend them, and we'll basically just get tickets for the giveaway. People who have been watching longer gonna have more of the nozzles to spend. So I think it's fair, right? So, and that's all not possible in YouTube. It's very much complicated, and Twitch is so much easier to do these kind of things. That's why we're doing this. So what are you doing? What are we doing today? Mad Scientist is also already hopped over to Twitch. I see you there. Great. You also tried out the nozzles. Yeah, that's great. So how's everyone doing? How's everyone doing? I've been waiting so long for streaming again. I don't know. I was so busy, and life is super busy for me at the moment. Honestly, I've been, yeah, work. My main job is consuming so much time now at the moment. I don't know. It's all things are changing also. So my job is changing, and next year I'm gonna have a team with 9 people. So that's different for me then. So I'm leading a team there at Amazon Web Services, and yeah, it's gonna be interesting. It's gonna be a huge change for myself, but even if things change, I don't intend to stop doing stuff like this and doing 3D printing. And the only thing that's different now is actually I found that, or I think that streaming, using streaming to interact with all of you guys is really so much easier at the moment, because I don't have to prepare so much in terms of recording and then editing, and we can just, I mean, I have to prepare some stuff, of course, for the streams, but in the end, when the stream is done, it's done. And the only thing that I've basically just do is maybe add a thumbnail for YouTube and then post it there. But essentially, I don't have to put so much time into the actual video editing. And I think we kind of have a lot of fun time together. And yeah, I liked it actually, the idea a lot. Twitch, Mad Scientist. Use Twitch through my OBS, seems to work quite well, and when I stream a print. Yeah, I've also tried that. That's actually a nice feature. There is in Octoprint, there's actually a way to add a plugin that streams directly to Twitch, for example, so you don't have to use OBS. So if you have an Octoprint with a camera, you can also have your printer always sending something to YouTube stream or your Twitch stream. It's also nice. Yeah. I tried Twitch, but it wants me to create a new password. Yeah, that's maybe the only downside, that you have another account besides YouTube in parallel if you wanna be on Twitch, even as a viewer. On the other hand, I think Twitch is so much more interactive. I think it's really worth going there. And I don't know so many 3D printing streamers. There's a few. There's also a German guy, Chaos Drucker. Yeah, he has a nice channel. So if you're from Germany and you wanna find a good German, or yeah, with a few interactions, or with a lot of interaction actually, then Chaos Drucker is also a good channel to go. He's mainly into the Voron stuff, so he's building Vorons all the time. I only see him building Vorons in every single stream. He's building something. Yeah, so it's much more investment. Return on invest, actually, it's a better return on invest, yeah. Editing is so time consuming, and I mean, the last few videos I've started using an editor again, so someone who edits my videos for me, because I figured I can't do it anymore. It's really so much time. So for me, it's much better to have someone helping me there and editing the stuff, and I still have to be very structured. Or the good thing about having an editor is that you have to be so much more structured, and give them the content in a way that they can like easily understand what you actually intend. So what's the intention of the video and how the story goes, and I think that forces me to be more structured, and it's just positive in a way. Make a deck. Yeah, that's why. Yeah, there's also there's quite a few 3D printing streamers. 24/7 stream of multiple people printing at the same time. Nice. So what are we doing tonight? I have prepared a few things. You have probably seen me talking about the. So I'm gonna turn off the music. Let me turn off the music first. I think we don't need that anymore. And it's a little easier for me to talk to you. So, let me know. I think we're good. Microphone is working well. If anything fails, then please let me know, either in the YouTube chat or in Twitch. So what are we doing tonight? The idea is I have posted quite a few. I think I lost it. So I was posting on Instagram, and I think we did one live stream. I think a few weeks ago, 2-3 weeks ago, where I've already prepared some of the parts for the V100 3D printer build. So the idea is that we are building the tool head today. Hopefully we're gonna get through. It's already quite late, but I'm trying hard to finish that. And so I've got all the parts here. Gonna make sure that we can, like from the top down, will I be able to show you more of the details. So the idea is that the tool head is essentially just the hot end and 3 fans and a few screws and bolts in there. I think it's probably one of the easiest parts to build, but I will just have to start. And the second thing that I'm currently doing, excuse me for a second. The other thing that I'm doing, I was going through the documentation for the V100. Basically, it's I think 5 videos on YouTube. And these 5 videos or 6 videos explain how to build a printer. And then there's also documentation or a written guide on Patreon from Matt, Printing Nerd. I didn't read that. Not that I believe that the guides are bad or something. Probably they are good. But I figured I want to create my own kind of manual or kind of document the process. And write a kind of a concise good manual how my version of the printer was built, and then basically do it in the same way how Prusa does their documentation, with pictures where you can see like what parts do I need in this step, where basically does the things go, right? And with different colors so you can be identifying, okay, this is the part with red and this goes here because that's marked red. So you exactly know like how things come together. When I was watching the build videos for this printer, I think the build videos aren't as concise as they could be. So there's lots of parts where Matt is just removing supports, and that takes like 3 minutes or something. And then there's other parts where he's doing threaded inserts, and that takes like you can fast forward that stuff. But then there's also parts where I think in the beginning he was starting to explain things quite detailed, and then at some point in some of the videos, he's just skipping over a few things, right? So he's like probably assuming that you know the things that he's talking about. So the video guide in partial, I would say it's probably the beginning is good, and then I think at some point he loses the viewer in a way. If you don't know what you're doing, you probably want to go for the written guide, and that's why I said, okay, let's make a written guide, or let's me document the process, and hopefully giving people who want to build this printer a little bit of a more in-depth, step-by-step guide. And that's why we're also going to take photos. While I'm going to take a lot of pictures of the different steps, so I can use them in my own blog post, which is essentially going to be a guide. So let's see. Yeah. Whatever I try as a password on Twitch is too weak. To them, Carmen. Oh my goodness, I can't help you there. You have to figure it out yourself. Use a password manager. I'm using LastPass. At least I think it's still secure enough. Like, they had some leaks in the past, but honestly, that's working for me. So what are we doing now? Basically, I won't walk you through the Z100 printer, what it is about in depth. Basically, it is a Core XY 3D printer, quite small, I would say. I think the print bed is 140-ish millimeters. So that's the build plate. So the print surface. I think yeah, how big is it? 100, no, it's actually 162 millimeters or something. So it's an Ender 2, what was it? I think Ender 2 Pro or something. So it's quite a small, like, it is a small build plate, but it's also a printer that's not supposed to be printing huge things, but it's more supposed to be quite fast. So it's supposed to be a fast 3D printer that's mostly 3D printed parts, a few metal rods for some parts, and yeah, basically that's it, right? So it's a 3D printed frame. I printed the parts that I already printed. I printed an ABS-X from Nobufil, which is an Austrian company. So they have quite an interesting selection of ABS filaments. So that's the company. So they have ABS. They started basically last year. It's a pretty new company in Austria. The good thing, or the interesting part of this company, is all of the filament is made from recycled industry filament or industry plastic. So they are using industry plastic, ABS, and then they're recycling that into filament. So that's the only way that they produce filament. They're not producing it from fresh plastic. All the filaments that they offer is recycling filament, and so that's great. And yeah, ABS-X is also kind of a composite that is a little bit less likely to warp, as you still need an enclosure, in my opinion, especially if you're doing bigger prints, but you can get away with smaller prints like 10 centimeters of length on the build plate. That's not gonna warp, even if you have no enclosure, but I still decided, or then I figured when the print parts get bigger, still better to have an enclosure so things don't warp. Yeah, it also doesn't smell that bad as normal ABS, but yeah, I'm pretty happy, and they have nice colors, so that's why I started using it for a while now. What are we going to do? Evening. Been waiting for this to move forward. Dean Davis, yeah. Hey Dean, how are you doing? Welcome to the channel. I've been also waiting. Like, parts haven't arrived that quickly. I think because of Black Friday, things were slowing down, and I was waiting for some of the parts to come, and they just didn't appear here. So that's why I also was delayed in this, and then I also had so many other things. But now we're here. We're starting. What we're doing in the first step is, and I said already, I'm gonna document a lot of the stuff that I'm doing tonight. So don't be mad at me if I just stop for a few seconds and taking pictures, because I want to use those pictures in in my written documentation. So the first step, and gonna bring it up here for myself as a reminder, is going to be we are going to create, or we're going to use the threaded inserts as one of the first things, and we're going to prepare the plastic parts that use the threaded inserts and do this as a first step in the build. So we have them done, and once we have done the threaded inserts for all of the parts, we can easily mount everything together. I will show you quickly the guide that I'm working on, what I'm talking about here, and why I think, yeah, once it's done, it's going to be hopefully useful. So let me bring it on screen. Screen sharing. Here we go. So this is my idea for the guide. I have started writing this guide, so there's quite a introduction part. There's sourcing. Sourcing is I created my own bill of materials. It is basically a copy of Matt's original one, and I'm changing it. Currently, I'm working on the bill of materials to finalize it. Also to update the prices that I had, because I think the prices aren't always correct. And then also sourcing some parts was a little bit different for me, so I'm also going to note that down there. The other thing is that it was missing a little bit from Matt's guide is how many parts do you exactly need to print for, like from which part you need how many. As in the Voron guides, I think in Voron guides it's a little bit better explained, where in each of every step you see how many parts you need from which, like physical parts like metal parts or screws, bolts, and then also what 3D printed parts you need. And that's the idea of this guide. It's going to be that I will explain here. I'm explaining like material choices that I made, print settings that I have, print orientation, support material tips, threaded inserts, tools, required tools. So I'm going to list all of the tools. I started basically figuring what tools I will need, and then we'll update the list. And then each assembly step will start with a picture. Today we're going to do the tool head. That's why we're starting here. And then like Prusa, I'm going to rank these different steps: easy, medium, difficult, and how many steps there are. So it's just the numbers currently just made up, because there's going to be lots of steps each part. And then I think yeah, each section is going to start with necessary tools, required hardware, required printed parts, right? So we're starting today with, like, this is all the hardware that we need. Hardware is essentially electronics and anything that's not 3D printed. I'm still missing to list how many threaded inserts we need for the step. I think it's good if we list all those things that we need at each and every step, like, and then we know what we need. And then we have the 3D printed parts listed here, and then like there's 2 different hot ends currently officially supported, but there's probably other people doing mods for other hot ends, but this is on the 2 different hot ends. And then we're starting with the first thing now, with inserting the heat press inserts, and then we're like working backwards from here, and then we're thinking about, okay, what pictures do we want to take from every step, and then we're gonna use those pictures and put them back into the guide, right? So that's good. I think for me that's my, yeah, forget full depth written guide. I'm honestly, I don't want to spoil myself by reading other people's guides. I don't want to copy paste from other people. I'm just want to document this for myself, right? So I want to document it here, and I want to post it on my website, and then you can like basically see what I've done, because my guide is going to be different from other people's guides, because I'm using different parts and I'm also doing different modifications, and I'm probably in the future also going to change the 3D printed parts to adapt them to my needs. So I think my printer in the end will be different from other people's printers. Yeah. That's why I'm just going to document it here, and then you can basically decide which one you want to use. That's what's going to happen. So I think that's, yeah, as again, I don't want to spoil myself too much with like using other people's guides. I've seen the videos, and I didn't want to copy paste from other people. So we are starting. Just want to show you also my little setup here. This is probably not the best thing to see. Here we go. So I have brought my, I've moved my little threaded insert workstation. I've been using this for my other projects. The way it is built, very simple. It's just essentially just a Dremel workstation, and there is an adapter here for a soldering iron, and you basically you can just pull the lever and push the threaded insert in. In the official guides or anyone else, I mean, there's so many people who told me already, yeah, but threaded inserts are doing, it's so easy to do threaded inserts. The thing is, with the project that I've done before, I have inserted probably a 1,000 threaded inserts. I must have been around about 1,000. And I think if you do hundreds of threaded inserts at some point, using a soldering iron and doing it manually is I mean, it's tedious. And the results are going to be different every single time, because you're like getting every single time the threaded insert inserted really vertical or horizontal flat. It's not easy. I mean, I would claim that you cannot get consistent results. I mean, you can do 5 threaded inserts manually, okay, but hundreds, I don't think so. I don't think you're going to be happy, especially if you do it for a customer. So, first step, just going to count how many inserts we need for this first part. We need 1, 2, 3, 4, and then gonna move stuff a little bit to get some better. So we need 4 threaded inserts for this part. We need 2 for this part. And we need, I think, 8. Yeah, this is the clamp. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. I think that should be all of the inserts for this piece. So this is total 14. Just gonna make a note here in my guide. 14 threaded inserts. And we have this, they have a special size. I think yeah, I'm gonna just leave it as that. Threaded insert or heat press inserts. I think I'm going to be consistent with the naming here. Heat press inserts. So we have 14 for the first step, right? And the first step in the guide is we're going to heat up the soldering iron. Kind of bring it into view. Yeah, so you can see it. Not easy here because, yeah, I think it's good. You can also have a look if you can see it from that perspective. Yeah, maybe that's also better. Maybe that's better. So we're gonna heat it up. Temperature is going to be, let me see, 200. Yeah, we have ABS. We're gonna do 240. Mark, welcome to the stream. I'm trying to figure out how to replace the filament in my machine. What are you talking about? Are you doing some kind of build, or are you? And my camera is kind of tilted. Yes, looks like the camera is tilted. Looks a little weird. Probably need to fix that. You know, not so happy. The camera tilted. Let's see if I can fix that. Kind of weird. Looking a little bit strange. This looks better. Hopefully it's now not tilted anymore. CNC Kitchen or Rothex. I think the heat press insert tips are from Rothex. So the tips are from Rothex, and the threaded inserts are from AliExpress. So yeah, I've got good experience with the Rothex heat press tips. Thing is, if you have a soldering iron, you need to figure out which one you need, like which kind of hot end tips you need, and they are working great. But you will see in a second how this works. Mark having problems with this 3D printer. I'm having difficult times to print stuff. So guys, maybe you can help Mark in the chat and help him a little bit. You're probably the experts also. I mean, you have a few people here that I know that are pretty good at stuff, and so maybe you wanna help out Mark in the chat while he's here. And again, I wanna briefly mention one thing before we start. If you hop over on Twitch and watch the stream on Twitch, you can basically earn so-called nozzles. I'm going to post the link once more, just to give you the link again. Here we go. So that's the Twitch stream. For posted this on the YouTube chat. There's not so many people yet over on Twitch. I know, because you probably subscribed to the channel and you're probably used to see all of the videos and streams on YouTube, and that's also going to stay, right? So you can still stay on YouTube. You can watch everything on YouTube. The only difference is that we are using Twitch for like a better more interactive thing in the future. And like you will see, I will mention this every single time I'm gonna stream. So eventually, probably people are gonna go over to Twitch. And on Twitch, you can earn nozzles, and nozzles going to be used for giveaways, right? So the more time you spend on the stream, watching the stream, you're going to earn more nozzles, and then you can spend them in a giveaway. And basically, the longer the watch, the more you get, and the more tickets basically you have into the giveaway, and that's how it works. What printer are you trying to fix? Yeah, Dean is already helpful on YouTube. Thank you for that. So let's continue with the build. So this thing is heated up. It's hot, 240 degrees. Soldering iron. I'm gonna start here with the first piece, and you will see this is super easy. I'm gonna just push one of the threaded inserts here into the hole, and then I'm just gonna use the lever and push it in, and that's super easy, right? It's gonna be perpendicular perfectly. Only thing is, I'm gonna rub it a little bit, so any excess filament that's creating a little bit of a bulk here, you're gonna push that back so it's flat, but super easy, right? And we can do it so many in such a short time. You can do so many threaded inserts, heat press inserts, and it's very convenient, and you don't have to touch anything with your hands, right? And it's super fast. And that's why I love it so much to use this setup here instead of doing it manually, holding the soldering iron. And that's just not convenient, right? So this is going pretty fast. So I'm not gonna do this one. Let me take a picture. That's what I told you. I'm gonna do a lot of pictures. That's my intention here, to show in the stream to show in the documentation how this is done. So let me take one picture, and then this is a little more complicated. While going down, taking another one, and then I'm using those pictures later in my doc. Just for illustration, not gonna take every single heat press insert a picture, but at least for the so that people will understand what I'm doing here a little better. So now I'm gonna push this up a little bit. The only downside of this setup is that the hot end or the soldering iron gets pretty hot over time, and it might be needed. You need to cool it down a bit later, so might be that we have to make a little break here. But we don't have so many thread inserts that it's going to be too warm. If this is running for 20 minutes or longer, then at some point this mount up here is going to get too warm, especially this upper part of the this is rubber, but it's still getting so warm over time that and I made the mistake that I printed this from PETG. I probably want to reprint this with ABS-X at some point, so make it a little more heat resistance. And thank you, Dean, for helping out in the chat. That's amazing. I love the community that we have here. Like, we have so many people always coming back to the channel and helping out, and also the Discord mods. I didn't really thank everyone enough, honestly. Forgot about that for a while, because it's just, I mean, it's not for granted, right? You have people that are willing to spend time and help other people, and I think we take that for granted, and it's definitely not, because it's a lot of time and also willingness to look stuff up and help with things. And I think that's definitely something that we should reward better in the future. So this is the first 8 red inserts. Pretty much done with this piece. So take a look. This is the result. Hopefully you can see it. I don't know. Here we go. So holding it in the wrong direction. So this is the threaded inserts. And that's super easy, super convenient with the Dremel setup. Very easy to do. And yeah, first part finished. We have to do a few more. We have the fan shroud here. And the good thing is really you have everything, always you have things perpendicular. So you just have to have a table, and ideally the parts are flat like this one. So it's flat on the table. It's easy to insert this piece and then just go. I want to push it a little bit here. Next one. Good. That looks good to me. We have another 2 here. I'm going to raise it up a little bit. Yeah, that's good. And you see, this is super easy because you can easily adjust the height in a matter of seconds if you have different types of parts. So another 2. One. We're gonna do them both same time. Good. And make it flat. Looks great. So this last one here, I'm gonna bring it down again. So this is the hot end mount. And you will see this coming together in a few minutes. Really just a matter of minutes how to see this coming together. Like it. So push it also. So could turn off the soldering iron, let it cool down. I think this we don't need it today anymore. Swivel it over. So the next step here, I will just put the parts here nicely on the table, take another picture of the final result for my little guide. So just to illustrate again how this should be looking. Yeah, that's great. So next step in my little guide here, securing the blower fan soldering points and wires. Yeah, I think I need to do that. It's also a preparation. This was one preparation step, was to do the threaded inserts. The next preparation is selecting the right dry lens, and I will show you right here on table what I mean. So we have these rods here, the linear rods, and they are going to be used for the x-axis, the y-axis, and the z-axis. Most important is probably the x and y-axis, because that's where the fast movements are going to happen. And in the guide, also in Matt's original videos, he was mentioning that quite important is to select the best dry lens for the job, and then that means you probably want to order a couple more of these dry lens to test out which ones are smooth and are not rubbing or not creating any like huge scratching noises on the rods. So what I will do now is I'm going to select 2 rods that I will dedicate for the x-axis, because that's the first that we want to go for, and then also selecting a good pair of dry lens for these rods, just to make sure we have, like, they are not kind of wobbling around, so they should be like pretty much, they shouldn't scratch on the rod. They should also not be too loose, so there shouldn't be any like slack if you try to turn it or push it. There shouldn't be any like slack, but they're all kind of a little bit slightly different. Like they're all slightly different. This one, for example, is a little more, it's a tighter. Still don't think that it's scratching, but it feels a little better. So I'm just doing a little selection here, which one I'm going to take finally. Yeah, this is also nice. This is a little loose, I would say. I wouldn't take that. This is also a little loose. Yeah, that's good. Yeah, it's basically two different groups here. That's nice. There was also a question in Matt's original video, like, why are you using these dry lens and why are you not using the normal linear bearings? And his explanation, and it's pretty much straightforward, is the dry lens are pretty silent. So if you move them, they're basically making no noise, right? You can't really hear anything. Especially when the printer is going to print faster, they are going to be much better. Because if you use the normal linear bearings, I'm going to try one here. You hear that? They're definitely creating some noise. And you can imagine if that's happening in a super fast moving printer, that can be a little annoying. And your printer is going to be much louder. So that's why I also went for the dry lens on the X and Y, and on the Z axis, it's fine to use the normal linear bearings. Could probably also use dry lens for everything, but I think the argument for not using dry lens on the Z axis is dry lens are like, if you want to do small movements like pushing up the print bed, and they could kind of like have some resistance or create some resistance initially. And I think the argument was that linear bearings or metal linear bearings are better for that because they are immediately moving. They have not this initial resistance. And dry lens have the tendency to have a little initial resistance before they start moving. And that could be like for these small movements of the print bed, that could be a problem. I'm not sure if this is really going to happen, but I think that was his argumentation why he thinks that dry lens are not so good for the Z-axis, but better for the faster movements of X and Y. But I don't know yet, so we're gonna see. You will never hear the bearings above the fans. Maybe. I moved away from dry lens and now using the new 100 motion system, I was getting binding. Yeah, I'm gonna try out this initial version myself, and then I think that the fun part of this printer is going to be that it is super modifiable, so you can like start building it like we're doing it now, using the parts that we have here, and then like swap out individual elements. I mean, there's so many options. I think this is the great thing about these kind of printers, is really they're so modular, and you can tinker so many stuff, and it's much more tinkering actually than with any other printer, because everything is printed and everything is modular. So I think we have a good selection of dry lens. Let me check out what I need in terms of pictures. I think I want to, I skipped a step. I will come back to that step in a second. I will take a picture of the rods here and some dry lens. So we need, yeah, two rods, two dry lens. I think I'm gonna use one picture from that, and then we're gonna put dry lens over. Kind of take a picture. That's a little bit harder to do. Yeah, we're gonna take a picture of the dry lens on the rod. Okay, I think the rest is going to be explained in text. It's just to have a few pictures for the blog post and the guide, so we know where we are, what we're doing, why we're doing it, and I can always come back and take a few more pictures later. So, Tutankhamen, I'm thinking about putting my printer's fans in another room and feed the air via flexi pipes. Yeah, I've seen a version of this printer where it's, I think the whole blower system is external and using flexi pipes. I mean, it's not so far from the truth that it's probably a good idea. So the next step here, I think, yeah, we wanna do another preparation step. I think we've done the dry lens now. Let me think about the next thing. We have these Sanon blower fans. They're pretty much very expensive. It's pretty high quality. I think I rarely pay that much for fans, but I recently had a few issues with cheaper ones, getting super hot, starting to basically smell like they would explode in a few seconds. So that's why I decided, okay, maybe it's not so good to have the cheapest fans in this printer, and if it's running for a long time, then they are gonna get even louder. So these Sanon fans should be quite good in that regard. But we'll see. I mean, could also be wrong. I'm just basically taking advice from Matt here and using better quality fans. So we have these Sanon fans. One suggestion that he had, and I also put this in my middle guide here, is to look into underneath the sticker here and to basically lift up the sticker or remove it. Doesn't really matter. And I already kind of ruined the sticker. So to pull it up and then take a look at the soldering points here. The problem with this cable is that if the printer is moving so fast and this cable gets in any situation out of this little gap here, out of this holding piece, it's just going to create so many vibrations, the printer, against these soldering points that these cables might come off. So that's why his suggestion is to secure these cables and to fix them, or to put some additional glue on top of the soldering points just to make sure that the cable is not moving and it's not wobbling and it's really fixed into place. I think I'm going to use hot glue for that. I was thinking about using AC glue, but you would have to put so much AC glue in here, and the AC glue is like flowing everywhere, and I'm a little afraid that the AC glue flowing into the fans, electronics, or anywhere where it shouldn't be is probably not such a good idea. They will be loud. Okay, Totem Carmen says the fan's gonna be loud. Yeah, there's so many people. Yeah, it's great. I think the community that's going to build for this printer is already amazing, and it's gonna be even better in a matter of weeks. So I think for tinkering, that's actually a great idea, great printer. I'm hoping for the best, and I'm expecting the worst. No, I mean, we're gonna be building this and I hope it's gonna work. Let's see. So I need my hot glue gun. That's the only thing that I forgot to bring. Mad Scientist is coming over on Twitch. Hey. I almost forgot that you have switched over to Twitch. Great, great. Don't forget to... I want to try out the command. So if you send nozzles, you will see how many you have. And there's already 9 people on the leaderboard, so it's like some people have already started watching the stream on Twitch and earning nozzles, loyalty points basically, for watching and continuing to watch. The loyalty points we're going to use for giveaways, so you can enter giveaways, and the more nozzles you have, the more chances you have to win. But it's not all. Yeah. Great, Mad Scientist. First ranked. And the longer you watch, the more you can get. Great. I'm gonna get my hot glue gun. I'm gonna be back in a few seconds. So we can continue securing our fans' cables. I'm back. So we need some glue sticks here. At least one replacement, I guess. So put it here. My little glue stick gun here probably needs a little time to heat up, so we'll probably have a little time to chat and see what everyone's doing. So let me know, what are you doing? Are you watching this at home or at work or wherever you are? Herb Wong, love your channel. It gave me a lot of valuable info. Yeah, great to have you here. I'm always happy to hear if I can be helpful. I think that was also, I don't know, I was struggling, last couple of weeks I was struggling a bit with making content because I was thinking there's so much stuff going on. There's so many new things coming out, and there's so many, like, I don't know, there was so many external things coming, new Bambu Lab printers, and I think at some point, even if you are kind of experienced, you're always getting like the shiny object syndrome, or like you're kind of missing out on stuff. And I was getting very busy in my like real life and kind of pulling back actually a little bit and seeing, okay, I want to focus on something, and I really want to put my energy into less things actually. And that's why I said, okay, I will start building this printer, and I think it's a nice print. Like, I think the Twitch overlay is a little too huge. Let me fix that. The Twitch alerts, yeah, it's a little big. Let me make it a little bit smaller. Okay, I think now it should be a tiny bit smaller at least. That's not always in my face. Hey, now on both streams. Line is on both streams now. Yeah, but it's only, I think you cannot watch them at the same time. Okay, great. So now I was just talking about what happened in the last couple of weeks. So I was like kind of busy finishing yeah, you can chat in both. I was kind of finishing this 3D printed computer case project, delivering the last parts. I think I made this video where I was kind of delivering the last batch, and then I was thinking, what can I do next? What's next up for me? Because I was getting a lot of requests from companies for reviews. I was thinking about that and was kind of not really that into it. And instead, I'm kind of discovered this project and said, okay, this is maybe it's time for me to build a new printer, just for fun, and really going like stepping back a little bit from all of that reviewing stuff and really going into builds again, and then maybe gathering some some experience again. Finding out how it is nowadays to build a Core X5 printer, and then just have some fun with you guys, because I think the community that I wasn't leveraging the communication for a long time. I was basically just shouting out in one direction, doing videos, but I wasn't that interacting with you guys. And I think that's for me currently the easiest to do that is really to go live, right? Because then we have the conversation, and then we can chat, and I don't have to put so much time into the editing, because that's super time consuming, and I don't have so much time at the moment for that. I really want to just enjoy this stuff, right? Enjoy the hobby, enjoy building once again. Okay, so we have the fans, and we have this little guy here. Let me see, can we get a little closer? So have the glue gun, and it's not big. The glue gun is actually pretty tiny, honestly. So my idea here is I'm going to take a few more pictures of this fan cable. That's a little difficult. Let's put it somewhere. So I want to have a picture of this before. So we see what's happening with the connectors. And then I will put some hot glue here to fix or secure those soldering points, because yeah, this is actually the topic. When they get when there's so much vibrations going on with the printer as it might be, then it's better to have them secured. And we're just gonna put the glue on and securing the cables in that way. A little bit here on the side. Yeah, that's probably good enough. Just there to be reducing the vibrations and the strain on the cables. Doing the same for the second one. Orange, you can also take a picture now. Can probably do a little more. Top here. It's fine. Yeah. Good. This one is done. Second one. Yeah, again, we are going to remove the sticker. Lift it up. Yeah, it really doesn't matter if we keep the sticker in the end, but we can also remove it completely. It doesn't matter so much, but I like it more with the sticker actually. So let's put more glue on here. The good thing about the hot glue is you can remove it if you need to. If you use the AC glue method, then there is basically no chance of replacing the cable anytime if you ever need to for any reason. It's basically not possible. Gonna destroy your fan otherwise. So I think this looks good. Does it work? Yeah. So this is how it looks when the hot glue is put on. It's securing the cable, so if the cable is in any way vibrating or under strain, it's not going to pull on the soldering points. So yeah, that's done. We have pictures of that. You just made me check my 100 fans, couldn't remember if I glued them. Actually, honestly, I came to the conclusion that this is a good idea, because I was having some doubts about, does it really make sense to secure the cables on these fans? And then on my Sovol SV06, I have replaced the hot end cooling fan with a 5015 fan, and the cables weren't secured. And this is a very short cable. That cable is only probably 10 centimeters long, going from the fan to the PCB board on the hot end, or on the, like, basically on the gantry. And for whatever reason, the cable was coming under strain. I think it was I think it was the filament run out. The filament ran out. The filament kind of tangled into the cable for whatever reason. It come underneath the cable, and then the printer moved, I think, to the left-hand side, and then it pulled on this little tiny cable and pulled it from the soldering point. It really pulled it off the soldering point. It was kind of probably very much, it wasn't that much force, but it was enough to remove the cable. So I had to solder it back on, and then I secured it with glue. So I can definitely confirm that this can happen. Yeah, it's absolutely possible. And this is not a it's not super fast printer, so it's like still printing at normal speeds. Good. So let me go back to my little manual here that I'm writing. Next step, we have secured the blower fan, soldering point and wires, selecting the best dry lens. We do that. Now we are pushing the dry lens into the hot end, the rod cradle as it's called. So this is the rod cradle. And what we're doing here, we're taking our dry lens. We have 4 good dry lens, identified them, and we're gonna push 2 into this rod cradle. Just pushing them in. And then we are going to use 2 or 1 to push it to the center. Basically just, yeah, we can also do it from the top. I think it's easier. Push it in. So that's easier. That one is a little... Okay, so that looks good. So the idea is that they are sitting in the middle of this, and once that is done, I think I'm gonna also take a picture here of the final thing. You can also put this one on top for illustrating the using the second dry lens to push stuff in. And then we can test out if this is still working, because the rod cradle is going to create a little more pressure, right? And if that is too much, we probably have to look for dry lens that are a little less tight, and that feels, for me, that feels a little bit too much, honestly. This one is much better. So although in the beginning this dry lens was working quite well outside of this cradle, now it feels like this is too much pressure. So there's some static pressure, so I'm probably gonna replace this. So this is a test that you will have to do this. How to push them out. Basically just push one through and then push them. Yeah, we can just replace it. This one is actually feeling a little better. So why don't we just push that through? So to replace it from the side. And use that to test the stuff. Yeah, and you can, it's so easy actually. Let's see if that works better. That's a little smoother, but I feel there's also quite a lot of pressure now. Maybe the second rod is, yeah, it's not easy. So my feeling is that this is actually the best one, and this is creating a little more pressure. We can also double check if there's anything in this tunnel here, or in this hole, that is pushing harder for any reason. But it looks pretty clean actually. Yeah, let's see. I mean, we can find probably another dry lens that is a little bit easier, like this one. I think that was one of the initial ones that was sliding very easily, but that could be the one that we need for this situation here. Could absolutely be a better choice. And that's why you need a few spare dry lens to test the stuff out, because they are all slightly different. And that's a little better, but I'm not so happy. Honestly, I'm not happy. This one is working quite well. That moves quite smoothly. Add binding at the front and the back. I also would suggest try another rod and a tight bearing. Yeah, let's see. I mean, this one here, we can have a good pair now. I think this is good. Yeah, we probably, it's a good suggestion from Spline 72 to test out different rods. This feels a little easier. Maybe we use that one. I still have the feeling that this is too much resistance. That's too much force. So we need a better combination. I wasn't anticipating that this is actually so much harder. I mean, this feels also nice, but it's still, they are all kind of easy to move, honestly. So we'd have to find something that is even better. So let's try to figure out if we have any other Drylin that is moving easier. And they are all good. I mean, this rod is probably a little bit smaller, less diameter. Seems to feel the same way. More resistance here. Yeah. So I think I would say this lower one is good, but the other ones are pretty much rubbing too much. So what's going on in the chat? Do you have any idea how to solve this issue? There might be a slight print artifact. I ran a file through mine to make sure. Yeah, that's maybe a good point. There might be something in this hole here that's pushing, it's creating some static pressure on the Drylin, and that might be a little different than on this side. Right? This side might be printed better, and there might be something in here that could be the point. The thing is, I need to get them out now. I need to get this Drylin out without basically pushing the other one in too much. I can probably push it. It's not easy. That's not easy. How to get it out without pushing another one in. Or we can try to figure out if there's any resistance in one of the sides here. And it's sticking quite well. Probably need to find something that is a little smaller to push it through. Let me see if I have something here. Maybe this adding is too big. This is a little smaller. This could be working. Yeah, that's good. So, is there anything in this part that's pushing? Yeah, there is something. Probably some print artifact that's pushing. Oh, Dean on YouTube. Okay, I see. You have different aliases on different platforms. I see. So I'm trying to figure out, is there anything in this part I can remove or file or make it smoother to remove this problem? Yeah, because this part, this Drylin is still, I mean, I think this is a little harder to move, but they are all quite easy on the specific rod. And even if I use other rods here, it's quite good. It moves easy. So maybe the filing stuff is a good idea. I'm gonna get some sandpaper, or I think a sandpaper is probably a better choice, and yeah, file it down kind of a little bit, sand it down just a tiny bit. Let's do that. So I have probably every single tool that you can imagine. Let's use some sandpaper. And try to figure, like maybe we can make it a little bit smoother using the sandpaper. Just giving it a few turns in every direction. Not too much, because if we do too much of that, you can also risk that it's going to be sliding too easily. And the point is, it gets stuck at the middle, and my feeling is that somewhere in the middle there is a point where there's a little more resistance with this part. For whatever reason, it doesn't feel like that. It's a tiny, tiny thing here. It's probably the issue. Let me see, which side is it? It's here on the inside. Yeah. Just want to spill this all over. So we have to clean the table afterwards. But anyways, just want to give it a few more tries. Where is it? Still there? Yeah, kind of. I think there's one layer line or something that's probably causing an issue. Might be that this is all we need to do. Okay, let's see if that solves the problem. At least this feels a little more like it's there's no thing that I can feel anymore. So it could be good. Let's figure which ones we are going to use finally. So this is good for first one. Let's see if this works. No. Okay, these are too much. This feels better. Oh yeah, this combination. This is good. So trying to push it in one more time. This is also easier now. See, I can also push it almost to the middle without. Yeah, this feels better. This is definitely better now. Before I couldn't really push it through. Now I can push it to the middle, and it's still not like it's not easily moving out of that position. Feels better now, but still, it's, in my opinion, still quite a difference. I'm still not happy, honestly. And I can imagine this is still going to create issues. So we probably still push it out one more time and file it down a bit more. Okay, we're gonna go with this one. I'm gonna keep it and then file it. Sand it down a bit more, just a tiny bit. So, how are you doing there? Hope you're good. Clean with a damp cloth, yeah. Maybe there is some leftover sanding powder. I wouldn't do much more now. I think this should be good. We have something to clean here. That's why old socks are still usable for stuff like this. Can probably just do we have some scissors here? Nope. Try to pull it through, but it's a little bit too much. But it can work. Okay. Good. Also cleaning this rod one more time. See if this is now okay. So give it one more try. Push it in. It's easier now. It's even easier. And let's see. My goodness. It's better. It's better, but not perfect. Not really perfect, and it could be better. I think there is such a I wasn't imagining that this is such a borderline thing. So you probably have to find that point where it's still not moving out, so the whole dry lint is not going to leave the hole or like easily being pushed around, but still enough pressure on that, or not that much pressure on the rod, but still enough pressure that it's staying in this part here. So let's see if we can do anything to make it better. If it's, I don't know, it's probably micrometers of difference that we are creating now. Don't want to do too much of that. I'm hoping to get to the clipper install before I do, so I can follow your guide. It's the only thing stopping me from finishing. Very fine sandpaper is best. Clean it up. Yeah, I mean, I have another sandpaper here that is also can use with water, so you can do wet sanding. Maybe that's another option. Honestly, I think it's the inside of this is pretty much perfect now. So if there's still a problem, then it's just too small, right? The overall hole. So let's figure out if this is working out. Feels easier, but not sure. We're getting there. Honestly, we're getting there. It's better, definitely better now than before. This is, I think this rod here is also smaller. It's definitely smaller. We can also try all of the rods one more time. But it's still very much, there's still quite a difference. Is there any better one here? This one feels better. Okay, so let's sort out these other ones here. Stay with this one. Okay, I think we're not yet done. I'm very sorry. I didn't anticipate this to be so time consuming. I have no idea. So let's try one more time. And this is, I think this is, what is this? The 250, yeah. So it's already pretty fine. Okay, we're doing it. We're doing it. Getting there. So how's everyone doing? Very fine sandpaper, yeah. I also think the constant in and out also helped the final fit on mine, yeah. Well, in the end, the things are going to wear out, right? So we are just basically in the beginning, everything is going to be super, super nicely fitting and then super tight. And then in the end, I don't know, 200 hours later, these rods are going to be becoming loose, widening up, and then you have to replace them anyways, right? So hey, new person here, new visitor, Rod3Bot GD. How are you doing? Where are you coming from? I think I can still see something in here. It's not making me happy. It's just in the middle, something that happened during the print. But not really, like, just barely visible. Maybe that's his issue. You can get rid of this problem. One layer line actually, or two layer lines that are kind of not 100% perfect in this part. Yeah, reprint it and start again after 1,000 hours. Might be the solution. Print slower. Just printing slower is always a good answer. We are building a printer that's supposed to print super fast, and we have to print it very slowly. Isn't that funny? There's an adjustable mod of that part. Thank you for that hint. Maybe I need to check it out at some point. This is kind of tedious, I guess. You would have to do that. Now I would say, is this much better? Let's see. Oh yes, that's good. I believe we can, I think we can go with that. This is still a little easier, but if we, I don't know, maybe it will anyways become easier over time, right? Yeah, why not? I mean, I think we can go with that. There's not so much difference now. Okay, so probably let's use it. Let's use it that way. So that was one important step to do, taking longer than expected. Let's see. We have to test this with the other rods and new combinations for the y-axis at a later time, once we get there. Anyways, so sandpaper gone. Now, one of the next steps is checking the belts here. Check whether the belts are working, or whether we can basically push the belts through here. Let me see where I have the GT2 belt. Here it is. So this is the one thing to check. It's just if the belts are coming through this part. There's 4 holes for securing the belts in place. The only thing that you need to check here is whether they can be pushed into all of the holes, and if there's some printing errors, that's not possible, but it seems so far this is working without any issues. So I'm going to take a picture of that as well, just to illustrate that in my little guide. Okay, that's great. So no problem here. Good to know. Next one, we have the hot end, and this is the Rapido UHF hot and ultra high flow. A few things to do here, a little bit of preparation. First of all, depends on the basically the two hot ends that are here listed in the official videos. CHC, I think it's CHC, and the Rapido. They both have their cables sticking out to the side, and that is going to be the position where they are going to run into the frame. So they're going to push into the frame, and that's why we have to basically remove, first of all, we need to remove this little cable zip tie here, and then we need to remove this arm that's holding it, or that's basically securing it here to the side, because this arm is going to be conflicting with this back panel here, with this back side of this part. It's going to push against it, or against, I think, the fan also, and I think it's going to push against the fan. So the cable is supposed to go through this part and come out at the top. And yeah, if we don't fix this, if we don't remove this arm here that's sticking out, or we probably can also just bend it up, but for that we still have to remove the zip tie here, because otherwise we're going to damage the cables. Where's all my tools? Goodness, I think I thought I had this, my little clipper here. Where's my clipper? Dang. Good. I'm gonna fetch it. Good. Okay, so I am removing this zip tie here. So now free to move it. And this little, yeah, there's a little metal arm here, and that's the same for the CHC. You can try to, either we can clip it off, which I have my doubts that this is possible now with this clipper tool. The other alternative is just to bend it upwards, but it's, the steel is not very good for that, so I try to clip it off. That tool is probably not strong enough for that. You can use this one, which I have not so much hope for that. Yeah, I probably need a stronger one, thicker one. Yeah, remove the metal plate, that's also in the guide, but I need a stronger clipper for that. So let me take a little picture of this so then we can see it, so it's a little more understandable what I'm doing here. Photo. Okay, now we are going to cut this off. This is probably the more suitable tool for that. So can we take a picture of this? Yeah, probably without the other one. Good. So try not to hurt myself. Still pretty difficult. This should be working now. already almost there. I think I need a little more pressure here. We have a side cutter. We don't have a side cutter here, but can still try. Wow, that's really strong. Still, it looks so small. Is there a screw? Ah, I see. Thanks for the hint. There is a little screw here underneath. It's very hard to see, actually. Might be the better way to do this. Okay. Okay, but then we have to completely undo the thing, right? So we have to disassemble this whole thing. Let's see. I was thinking this is easier, but I was wrong. So let's try it and remove the part. Removing the heating cartridge or the whole assembly here. Is that possible now? Probably screwing it off. Is it? Don't want to destroy anything now. It just pushed in. Yeah, it's just basically just yeah, and there's another screw here that's securing it. So probably have to tighten that up later. Okay. So this tiny screw here, probably a smaller one or not. This is holding. Yeah, we probably wanna. Ah, damn it! I wanna document that. I think that is. It's probably the better way to do this for the Rapido. So let's do the following. I'm going to take a little picture from this position. And then we're going to reverse engineer a step, basically, to show it. Yeah, thank you for the hint that there is a little screw here. I would have probably not seen that. Okay, so we can see that now. Now we're gonna bring this all together again. And hopefully doing it in the right direction. Let's see. If we are just imagining that this is the position this is going to be mounted, is it going to be fitting into our mount like it's supposed to be? I'm just going to assemble that first. So we will take another picture from this side just to maybe, and then we're going to basically explain in the manual just a reverse order of things. So pointing out that we need to remove these 3 screws and then we can remove this other one. Come on, let me place it. Here we go. Do it from this side so we don't see the missing part. Not confusing people. Okay, I think this is good. Okay, so can we still mount it in this holding piece? Is it working? Now it's pointing to the side. I'm not sure if that is a good idea actually. I think we should turn it in the other direction. Oh yeah, that's a bit better. But I think if we turn it, yeah, I think we're going to turn it in the left-hand side. just one hole. I hope that's going to make the cable align with the backside a little bit better. Yeah, could be good call out to not bend the cables too much. So let me take a note there. I think it's a good thing. So this is good. I think the position is now better. Hopefully we have a better chance to align this now. Yeah, I think the cables are now coming to the front a bit better, and we should probably take a picture of this and say, be careful in the manual, be careful not to bend the cables too much. So because they have also soldering points, and if you are pushing or pulling too much on these soldering points, they might also come loose. Let me make a note here. Note. Okay, so I don't forget that. So now the the ultra high flow hot end is ready. The cable is going up. The idea now is that we are putting this together. So that means we are inserting the hot end into this mounting piece. It should clip into a position here quite easily, actually. We have to fix this last screw here on the side. Probably also making a picture of that. I mean, I rather have too many pictures of these steps and then think about whether I want to keep all of them in the guide, than not having enough pictures and having to undo stuff and then, yeah, having issues. So this should be fine now. Another thing, I mean, we can probably do this as also for the pictures. We can undo this nozzle here. This is the default nozzle that's coming with the hot end. So I'm just going to remove it. Maybe take one more picture of the hot end or this the nozzle while it's in, and then I will remove it and replace it with the CHT. I think it's CHT. So let's have that. So we're gonna replace the nozzle. It's a Volcano nozzle on the ultra high flow hot end. There's a little adapter piece here that is the extender, so we can have the Rapido, the Volcano nozzles going in instead of the shorter ones, the default E3D. That is the replacement one. It is it's a CHT if I'm not wrong. So that should be. Then the filament goes inside. It's split into 3 little channels. You can't see that here. There is some illustrations. And then the filament is basically running in 3 little channels through the whole thing, and then at the end it's going to come together again. So that is supposed to make it flow faster. Yeah. And I have never tested that, but this is actually my first printer where I'm going to use this different type of nozzle to have a higher flow rate. and we'll see. Hopefully we're gonna have higher flow rates than the defaults. So there is a few, I think there's a tool in here, part of this package, to tighten this piece a little better. Let's see. That is that fitting? Yeah, this is fitting the extender. So the extender is in place. And we have to hot tighten the nozzle anyways. I think we can now, I think it's now pretty much secure already. Not sure if this is the best way to do it, if we should first screw that in, and I'll probably also tighten up the extender. I think we're gonna do this while this thing is hot. Not important now. We should have access to that. Hopefully we're gonna have access to that even if it's mounted. So next step, also to document, we need to do that, is bring that into the holder and fixing it. So this part should be clipping into its place now. Yeah, that looks great. So this is the next step. So this is the holding bracket for the hot end. Fits quite well. I think I was doing some Instagram post, like this is really fitting so well. There's almost zero gap here. So I'm gonna take a little picture of that. And now this next step is there's a counterpart here, a little holding bracket, or that's going to create a little pressure to hold it in place. But oh yeah, made a mistake here. We have to mount this first to the back panel. I think this is confused the steps. So first we have to take this part here and then mount it on top, and then we can insert the hot end, because we are not able to reach these screws anymore. So let's take it, let's have it oriented correctly. This is the way. This is how it's going to fit in. And the nozzle is pointing down, so it's going to be oriented this way. So let's take a picture of that first. Maybe without, like, just having this sitting on the side a tiny bit, then putting it on top here. The size of screw is, there is a render of the printer, yeah, I can pull it up just in a second. That should be the 6mm M3. So we're gonna take our 6mm M3 pack here. Should be over here. We have, this is M3 by 12, 10, 6. No. So we need 4. Now I'm probably gonna take a picture of these 4 screws with the part nicely aligned together. Yeah, because we want to have nice pictures for the dog, right? So 4 screws here, and then we are putting them, aligning this part and then inserting the screws. That is actually a little hard, not easy to reach. Yeah. This magnetic still, no, not working. Magnetizer for rescue. Is there a render? Yeah. As I said, and there's going to be, I've got it loaded into Fusion. Let me start Fusion and meanwhile, so we can basically just have it visible later. So I can show it to you. So hopefully this is working. Oh, damn it. It's not strong enough. I think that, I don't know why. Sometimes this is working, sometimes the screws are not magnetizable. Aren't these too short? M3 by 6. Is this really true? Or is this too short? M3 6 screws. M3 12, but only 2? That's actually a little strange, honestly. That is also a little bit strange. Maybe these screws are not working for the CH or the ultra high flow. Maybe that is something to remind myself in the documentation. Might be that M36 is too short for this specific mount. Yeah, the CHT is a different hot end. Might be that the screws are shorter for that one. Which sounds weird because that means the mounting part has a thinner, yeah, it's probably a 1 or 2 millimeter thinner, which means it's a little weaker. So the question is, which ones are we going to use? Maybe we're going for the 10 millimeters. Let's see. We have M3 by 12. We have M3 by M3 by 10. Let's test out if that works better. How much longer are they? Is it too much? Yeah, that could be working, but it could also be already too much. I can test it out. How much we have? How much space we have? I think we don't have enough room for this. Maybe hitting. I'm not sure if we are already hitting the end. The 10 millimeter could be working. Could be working. I think they are a tiny bit too long, but that's really borderline. I think we can use the 10 millimeters. I will put it in the guide as a first version and have it distinguish here. But I didn't print the other mount for the other hot end type for the CHT. Let's see. CHT. No, CHC Pro. It's called CHC Pro. So we have to, that's a good call out. I think we need to distinguish here and say we need different mounting screws. So let's say we are also mentioning that here in the guide. You can't see that now, but I'm putting it in my guide as a note, M3 by 10 millimeter screws. And for the CHC Pro, we need, I have to double check if that's true. I'm just gonna say M4 times M3 by 6 millimeter screws with a question mark because I have to check that. Probably I'm just gonna print the part and double check if this is really true, if they are really that much shorter. I hardly can imagine that this part is so much thinner, but I mean 4 millimeters of difference, and it was really not coming out. The screw was not sticking out of this holding bracket here. So if the other one is actually 4 millimeters thinner, I can't hardly imagine that this can be any stable, but maybe I'm wrong. So for the Rapido, I made a note that I will use 4 M310. So let's take another picture with these 4 screws here. And then move on. Let's move on. So Okay, so this is first step, and we are pushing them in. Maybe I need to reprint this part anyways. I'm not so sure. But let's see. Let's see. Not so stable, honestly. I think I broke it already here. There was probably a little bit of a, I don't know, little layer adhesion issue. So I will have to use some AC glue to fix this. There's a little crack here. Probably not a huge problem, but I wanna secure it. So let's see. Let's take one last picture here from the mounting story, and then we can move on. I'm probably going to change the order of things in the manual a bit, depending what fits better, but for now I think we're good. We're still doing some preparation work. The next step is really the one that we basically just did too early, pushing this in. The hot end comes in from the top. Just need to find the right spot. Push it in. Here we go. So maybe want to take a picture of that again. Yeah, the CHC Pro. I give up on Twitch. It wants me to verify my account twice and refuses to accept my photo. Oh my goodness, Tutankhamen, he has like so many issues. Maybe it's just not your day today. Maybe it's you have a bad day, and you should maybe try tomorrow. Maybe try tomorrow. Okay, so we're putting this part, this little holding bracket over. So let's have a photo of that. I think the screw length for that part was 12 millimeters. I'm actually pretty sure about that because that was the only longer screws used in this whole build, in this whole step. So where are the 12 millimeter ones? Here we go. Use 12 millimeter ones. I used Matt's video and had to watch it at 0.25 speed to see the fine detail, also then referencing the written guide in the printable description to fill the gaps. Yeah, that's why my intention is to document all of the little things, even though I now realized, okay, I probably have to rewind myself and replace a few of the images, delete some of the pictures that we have already taken, but I think I can still remember that. And I'm going piece by piece. So once we have done this first tool head assembly part, I will basically just finish that step completely with all of the images, and then basically just double checking myself 3 times to be sure that I'm doing things in the right order and I'm not missing anything. But you see, documenting is always much harder than just doing stuff. Just if you have to document stuff at the same time, it's always more work. It's always more time going into this. It's always slower. So as I said in the beginning, don't be mad at me for doing all the pictures and then going back and forth, because I'm figuring it out while I'm doing it, and I want to also have a good documentation of what I did in the end, right? So, and that's not super easy. Good. We still can see this little crack here. I'm probably gonna do some AC glue here on the side, just to have it just doesn't break while printing due to the vibrations. Anyways, I'm not going to stop here. I'm probably just going to undo the part later. So next part is we have this hot end shroud. And we have the hot end fan. This is the, I think it's was it a 4010 fan? A proper comprehensive guide will be great for the community. Yeah, that's basically why I'm doing it. I think it is, Matt did a great job designing all of this. I don't want to criticize his doc too much. I think he's probably running into the same issue as most of us are when we are becoming an expert on something. The biggest problem for experts is always to remind themselves that they are doing this for the beginners, and so they have to take a step back and really write stuff from the position or from the point of view of a beginner. Is not easy for an engineer, because engineers are used to talk to engineers, right? So, and engineering talk is always more on a higher level, or in matters how you see it, but, or could say low level, because they understand all of the terms, all of the details are kind of an agreement between engineers. And that's why it's super hard for engineers to come down to the level of beginners and really explain all of these details. Remind themselves that you have to do this and have to tell people like, okay, this is not a granted knowledge. You have to go back and explain all the little things. I'm not using the Banana Pi. I'm going with, I have two ideas. First one is the Raspberry Pi Zero 2W, because honestly, I'm not such a great fan of Banana Pi or all these like clones, and it's in my opinion, it's, if you would go for any of these clones, it's a very niche thing, but a Raspberry Pi basically works for everyone. So if I would say you can use any Raspberry Pi from Raspberry Pi 3B Plus to 02W or Raspberry Pi 4, Raspberry Pi 5, all of these will basically, there's going to be the same software installation steps and not going to be different in any ways, except there might be a different mount be used. But all of the Raspberry Pis were gonna, and honestly, the 02W is so cheap that I don't see a real reason why I would go for any other thing. And then the second one that is a clone, but I kind of fell in love with that thing, is the BigTreeTech Pi 1.2, right? So I've used it in other Clipper projects now, and I think it's just a perfect thing. It has one major advantage that I see. It can be powered over 24 volts directly, which can, I mean, you can circumvent that by using jumper wires and connecting them to the main board. But yeah, anyways, I think the BigTreeTech Pi 1.2 is a great alternative. It's quite cheap and has a lot of options. For this specific printer, it might be overkill, but yeah. So I think that's my two choices. So I'm taking one more picture here. What we're doing now is we're pushing this fan in. I think that's actually a very nice design choice, is to push, to have this fan going into this little slot here without any screws. And I hope I'm not breaking anything. So we just push this through, and then it comes out here on the other end, right, at the lower end, until it reaches the very end of this slot here. And once it's at the end, it's basically not moving anymore, right? It's just fixed in position. You see, this is the other side. It's not moving. So, and it can also be easily replaced by just pushing it back into the other direction. So, clever way. I think that is a really nice time. Nice design choice. No sanding. No sanding. It really fits very nicely. Good. This is done. Maybe take another picture from this side, so it's clear which direction the fan blades are pointing. I mean, that's probably one thing that you do the whole assembly, and then you realize at the very end of this whole thing, I have inserted this fan in the wrong direction. The fan blades are pointing outwards, or the direction is outwards. Okay, so next step, and I hope I'm not skipping over things here. Yeah, this is a step that I will probably put in the manual at a later point in time, because we missed something here. We have think we have this bracket here. Let's check back. Oh my goodness, where does this bracket go? I think, is this even needed for this specific version? I'm not 100% sure, honestly. Oh, yes, it is. I think this is going here. Yeah. This is going here. This is going here. And this is the counterpart. I think this is actually done at the end. Yeah, this is done at the end. So, the next step here. We need to push the cable through. And we should probably remove this protection thing, because this is really not having any purpose except protecting the cables while they are still in the box, but they have no function when it's mounted somewhere. Yeah, so we have two little plugs here. And we have to get rid of this shrink tube. So, what about the battery of my microphone? That's still good, because last time when we were talking, at some point the battery died and I didn't realize it for 5 minutes until someone in chat shouted so loud that we can't hear you anymore. And so, okay. Yeah. Thank you. I think Spline, how far are you into this build? Are you already done with the physical setup? I think you're pretty far ahead. So, I want to document that we are pushing these cables through this little gap here. We have to do it after we have pushed through the fan. Otherwise, I think it won't work. So let's have a little picture of this while we are like pushing the cables through. Maybe from a little more distance. Okay. So we're pushing these cables through, and then we are pushing the whole mount in this specific slot here. So it's going, probably want to align it. We want to align it. So you see this part aligned with this part. Yeah, let's do another picture. And then we're pushing it in. Until it's completely inserted, and I hope nothing blocking our path here. You see the cable from the hot end is very tight. It's very close to the fan. Now it's hard to see from that distance, but it's, yeah, there's not much space here. And once we have pushed this together completely, probably zero gap. Okay. Important detail is that the fan is still, yeah, alongside. I think there is, I mean, they are coming on the side, but they're still not, it's not really, there is no space actually to have the cable completely being out of the way. It's still like, it's still going here, at this point here is still touching the fan. There's no way around that, right? So here is the point where it touches the fan, and this, even if it goes to the side, it's basically not possible to have it not touch the fan. Doesn't really work. If I look from the top, there's also no room for the cable to go, right? So there's no no way the cable can really go completely here on the side. It's always going to be in this path here behind the fan. See, there's no real space for that, honestly. But it's going to be somewhere behind the fan. Maybe that's also the, I don't know if the CHD Pro is, yeah, you say it's blind. It's probably the CHD Pro is a little better in that regard. There's more space. I agree. I'm not so happy about the cables being so close, and like, how can we get this out? It's pretty much stuck now. Yeah, the print is pretty tight. I mean, it was easy to push it in, but it's not super easy to get it out, and something cracked. I think that part that what I already had glued. Layer adhesion. Not super happy about that, honestly. Probably I have to reprint the parts at some point. But for testing this out, this is probably good enough, and then we'll probably have to work on the, I think that the thickness of this part is critical. This is so thin here. This is the part that's holding the 5015 fans. This piece of plastic is so narrow, so thin. I would be wondering, it makes sense to make it a little bit thicker here. I don't know. Yeah, it has to be this way now. No way around it. For now, it's really difficult. I would just keep it as it is, I would say, and then we'll see how far we can go. If we have to reprint the parts and maybe, I think, make them a little thicker. Anyways, cables are coming out here, so we probably want to document that. Now the next step is to have this mounting bracket here on the front, and if I'm not mistaken, we need 4 M3 by 6 millimeter for that. But it could also be that these are still too short. I'm not sure. Let's see if that works. That could be working. Yeah. So they are not too short. We'll use 4. We also probably want to, yeah, later on we want to push over this silicone part for the hot end, the sock, but I'm not going to do this now because I want to tighten up the nozzle later once this is heating up, and then later as a last step really push this silicone sock over, so I'm not going to do it now. Here we go. So we have 4 screws. We have this piece here. We want to take a picture. Yeah, you will be. I will be definitely going to disassemble stuff. Right, this is my first attempt, and I'm probably going to reprint some stuff. I already see that coming. Honestly, I'm not completely. I'm completely with you. It's probably necessary. So, can we make this go in? Yes. Okay. Let's see. Push it in the right position. Fix it in place. Here we go. So, final thing. Last 2 screws. That's the good part about this build. I think I'm not so much worried about reprinting stuff because anyways everything is 3D printed, so, and that's basically what you should accept when you build this printer is maybe things are going to break when you are running this printer at high speeds. I'm pretty sure that there's a good chance that things are going to break at some point if you really do extensive testing, or you're running this for multiple hundreds of hours. But then it's also not so bad, because you can always print stuff again, right? So it's not a huge issue. Good. Let's take a final picture of this part here. We have those 4 mounting screws are in place, and that is almost done now. Almost done now. So last thing is we want to mount the blower fans. The blower fans basically just come on from the top. And we want to do, I think it was in the doc or in the videos, we also need thread inserts in the fans. I'm just going to quickly do that. So we're taking the fan, figuring out which side is facing outwards, right? So find the right place, right position. And then this side is facing outwards. So I'm going to insert 2 thread inserts into the fan. So power. Same procedure as in the beginning. We use my Dremel station and the special tips to push in the thread inserts, and then we do the same procedure for the other fan, for the other side. Other screws first, looking good. I'm talking from experience. You will be taking the hot end assembly part again, yeah. Again, and then maybe at some point you are going to be happy. But did you have this problem that parts are cracking because they are too thin? I would be interested, because this seems to be kind of a problem. Depends also on the material, but my material is ABS, and maybe ABS is a more, especially because it's cooling down. When it's cooling down, it's going to create, when the parts are very thin, probably likelihood of parts cracking is higher. That could be a problem. So maybe we need to adapt that part. That's why I said my guide is going to be really my guide for my printer and my experiences, and that might be different for other people. So I'm definitely happy to write as a guide that is completely different from any other person's guide to build this printer, because it's going to reflect what I have discovered, and maybe your, as you might say, the mileage varies for everyone. So these are 2 threaded inserts. We're done for the first fan. My friends, we're getting close to the end, at least for this specific part. That was my goal for today. So I am taking another picture of this. Good. So we can show the final result, that this is facing this in the right direction. I think this is important that we are documenting that. Go, go, go. Okay. Is this easier to, is there a chance to take a picture of this? Yeah, can do it. Good. Now we are also using the same screws, the short ones, M3x6, fixing that thing in place, and then we are repeating this for the second fan, and then we should be done for this thing. And I think Matt mentioned that he is using a long, I think M3 35mm one, going through here to have the cables being pushed to the back. I think that's actually a nice idea. Still, this cable here is looking a little, yeah, it's dangling around. I'm not sure how we're going to make this. Maybe we're going to run it underneath and then to the back. Let me see. I think that's the better way to do it. Run it to the back and then have it running here, going behind and then up. Let's see if that works. So we're taking the second fan and figuring out which way it goes. So this is the orientation. This is pointing outwards, and now we're doing the thread inserts. To be expected that this goes out in the other direction. Good. Looking good. And let's go. Come on. Pushing in the last one. Good. Okay. Still hot. Still quite hot. So this is the final thing. Switching off my soldering iron. Good. We want to make sure that the cables are all fixed in place, so not conflicting with the fans. Same is true for this one. So I want to make sure the cable doesn't run anywhere where there's an inlet. So can we make this, maybe do this at the end, trying to push all of the cables to the back. Okay, so I'll just fix it once here at the front. And you see, I've already glued this part with the AC glue because it was already broken in the beginning when I started just trying out the fit of parts. Yeah, how do we run these cables? I'm not 100% sure where to put them. I think we will just hot glue them to the top of the fans. I mean, this is probably the easier way to do it. Just having them sitting right here on the top. Still, all the other cables are coming out nicely to the back. I'm wondering, can we push them on to the back first? I don't think that this is a good idea. Well, it could work. So last, I think, yeah, but here we have a conflict here. This cable is probably going to touch the fan here on the inside. So I don't really like that. So probably for the blower fans, we're going to keep them outside of this channel. The other cables here, the suggestion was to use a long screw going completely from end to end and then preventing these cables from ever coming forward. I think we have this one here, M335. I think this was in the manual. Is this long enough? No, it's not long enough. Well, it could be. Yeah, it could be long enough. Honestly, it could be long enough. If we have, we could basically have another one coming in from the counter. What is going on? Are you not in place? Here we go. So we will insert the screw from the side. push it all the way through, or screw it all in. Maybe let's take a picture from that point of view. And then going all the way through. Yeah, and that's here you see the why this is useful, because these cables are then just fixed to the back. They are not going to come in this channel here, which is definitely useful. So and then we can use another final M3 6mm from the other side. So, and then all the fans are should be fixed. But I have one thing I need to fix it in my little guide here. We need 10 times. We need probably 11 for that. Yeah, need to count one more time the screws. I think it's 1 M3, 1 M3, 12 and 2 M3. Okay, should be good. Now, this looks good. I think we're done. Last thing to check here. We can now take these rods, push them through one more time, and yeah, see how well they work. But now I feel this looks great. This is moving quite well. So let's take a final picture of that. So the tool head is done. Kind of lost. Is there still activity in the chat? I don't see it. Let me see. Kind of lost the chat, if I'm not wrong. I hope so. I hope it is still working. Let's see. Yes, chat is still working. Okay, great. Let's take a final picture of this. And maybe also for the last illustration here to show this screw here that is keeping the cables from coming forward. Quite useful. Okay, good. So let's do a thumbnail image. From the top, so we see, okay, everything's done. The thing is assembled. I guess that's it for tonight. It's pretty late already, 12:30 in Germany. Thanks for being part of the stream. I hope it wasn't too boring. I mean, I was learning on the way. We have been assembling this hot end here, the tool head of the V100 printer. It looks great so far. All of the parts are fitting together nicely. There was a little bit of a struggle to get these drylins selected, and also cleaning out the channel here for this mount. So the drylins are running smoothly. I hope they are going to be running even smoother in the future when the printer is being used for a while. Everything else looked good. Again, I want to thank everyone for coming. It's getting late now, but I'm looking forward to the next part. The next part is going to be assembling the top frame, which means we're going to use the tool head and we're going to assemble the top frame, and we are inserting the tool head into the top frame, bringing these two parts together. And so if we can achieve that next time, we can test out the motion system in the X and Y axis. At least we can figure out, is it running smoothly? And then, yeah, I'm just following Matt's guide, but my next step is going to be now, I'm gonna double check all of the pictures that I made in my guide, and then really writing that guide, part one, basically finishing that guide. So I'm really covering all of the things that we've seen today, all of the issues that I had. I'm gonna elaborate a little bit longer on my problems here. And then I will publish the guide. Twitch chat died, really? Twitch chat, I think Twitch chat is still working, I guess. Because Blind did just post a message. Can you just do it one more time? I'll try myself. Nozzles. Let's see. I think Twitch chat is the chat that is on stream, right? So you can see it on the screen now. And it should working. It should be working. The only thing that doesn't work is that YouTube chat is not showing up here on screen, right? You can still post me messages on YouTube and I will see them. But I can't bring it up both at the same time, because that's, first of all, I mean, it's a little confusing for everyone. And it's also against the Twitch policy, so don't want to interrupt with that. Good. I mean, I should have been drinking more water. I'm going to bed now. So we'll see each other next time. Have a nice weekend. I'm gonna be super busy this weekend. We're gonna probably do, if I have time, I'm gonna continue later next week on Thursday, maybe. I don't know which time exactly. I'm trying to announce it a little bit earlier than today, so you can be part of it. Anyways, always available. Gonna be the replays on YouTube, so you can rewatch the stuff and see how I'm doing here. And I'm happy to have you back again. I mean, anywhere, anytime. So see you next time. Bye bye. Good night. Good weekend.